This week on QDL, wouldn't it be awesome if high school students had access to cutting-edge tools similar to what they might be find today on today's high-tech shop floors? Well, actually, they can. And Adam Sebran, Business Development Manager for 3D and Education at Roland DGA, would tell us about some of the cool desktop tools that Roland is selling to high schools around the country. Come back in 30 seconds to find out more. Welcome back to QDL. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk DeSharm, Editor-in-Chief of Quality Digest. So, as we all know, STEM education, science, technology, engineering, math, is a big topic today. Schools are spending millions of dollars to update their curriculum and update their equipment in order to teach STEM topics. And for those that are interested in showing how STEM topics tie into industry, having hands-on access to things like CNCs or large format printers or engravers, vinyl cutters and so forth can really add interest and excitement to classroom learning. Well, the problem is, obviously, actual shop floor, professional grade, high-end CNC milling machines, for instance, or 3D printers, are way too expensive for high schools and even for a lot of junior colleges. However, as with 3D printers, there are desktop versions of much of the shop floor equipment that you might see in industry. Companies like Roland DGA are leading the way in getting this equipment into schools. And joining us today is Adam Sebran, Business Development Manager for 3D and Education at Roland DGA. Thanks for joining us, Adam.
Thank you.
So, as I was saying, schools are spending millions on STEM education. It's been a huge topic, really ramping up over the last 10 years or so. So science, technology, engineering, and math education are a big deal. Lots of money going into it. From your perspective, how much of that money is going toward equipment, the type of equipment, let's say, that Roland sells, and has that been ramping up? Are you seeing an increase where people really want to get hands-on with the equipment rather than just teaching the topics?
There's a lot of money that's being funneled into, especially the category CNC machines that you're talking about. For example, you have a big Haas machine on a shop floor. It doesn't exactly fit in a classroom. You don't necessarily have electricity for it to be able to run it. So we put a little desktop unit up in the classroom, and we give it an interface that allows the student to be able to walk up to the machine and get friendly with that CNC machine without the hazards, without the difficulties, and without the difficulties of CNC programming or CAM. So we're able to take an STL file with one of these machines and simply import it into the software, run through a very quick 5-step wizard of questions that are asked in plain English. There's no conversational G code. There's nothing going on that's ultra complicated. And at the end of this 5-step wizard, the student presses start and the machine starts milling their project.
So I was going to ask you about the interface because I know your background before going to work for Roland. You worked in machine automation companies, machine automation industries. So I'm assuming, as you kind of alluded to here, that the interface for the milling machine is not going to be some sort of high-end programming language that the students have to learn. They really can get up and running on these pretty quickly.
That's a true statement. So out on the shop floor, the machines that I used to sell, I would have to go in and teach operators how to compensate for lead-ins and lead-outs and feed rates and dwells, spindle speeds, all kinds of factors that go into the machining process. And the software that Roland has created basically eliminates all of that and just allows the student focus on English-based questions about the geometry and about the model that they've imported.
So essentially, pretty quickly after they conceptualize what they want to make, maybe they create a CAD drawing, they can go from that drawing to starting to produce a product, produce their end result pretty quickly.
Very true. And this technology gets utilized by engineers in the real world, and we're now talking about engineering students. They design a model in their 3D CAD program, and it would really be nice to, at the end of the day, the end of the classroom day, be able to hold the model in their hand and have it machined for them without having to go to the shop floor. And that's what these desktop machines are about. That's what SRP Player software is all about.
And that's the software.
Answer the 5 questions and click start.
So let's talk. We got a couple of video clips that you sent over of some of your equipment. So I believe this first one is your desktop milling machine. Why don't we run that, and you can tell us a little bit about the equipment and so forth.
So the machine that you're watching operate right now is called the MDX50. And the MDX50, for under $10,000, you have a 3-axis milling machine that has a 5-position automatic tool changer that allows for tool changes in the middle of the operation so that the student can go from a rough tool to a fine tool without having to interrupt the machine and stop it to change that tool.
And what kind of material can they cut with this?
You're going to be able to cut materials as soft as modeling wax and urethane foams to a hardness of acrylic and all of the mechanical plastics, UHMW, Teflon, nylon, Delrin. There's a whole family of mechanical plastics or engineering plastics that the machine just loves to work with.
And we can't see it here, but this you did mention this is a desktop machine, so this is we can't see it, but kind of roughly, what are the dimensions? What, a couple feet wide, something like that, or?
It's about 36 inches square and 36 inches tall.
Okay. So desktop, but got a little bit of size to it. Okay, I believe the next clip we've got here is a vinyl cutter.
Yes, the GS24. So the GS24 is a 24-inch wide vinyl cutter. Works on XY coordinates. Basically, the vinyl is on a carrier sheet, and the carrier sheet is being propelled through grit rollers that you can see there. So the material is moving back and forth in the y-axis, and then on the x-axis, the knife is moving back and forth, causing a cutting activity where you can cut the pressure-sensitive vinyl, weed away the excess vinyl, and you end up with a decal that you could put on the side of a vehicle or a classroom or a machine, or that's how signs are done today.
Okay.
Cut vinyl graphics.
So I was going to say, so give us an example of, so you work, I believe you said your kind of your market for yourself is K through 12. How are you seeing this equipment used in the schools that you deal with? I mean, are the kids just making stuff, or is it strictly a teaching tool, or how does that work?
Well, I think that the classic way to look at this is to say, what are they teaching in the way of a curriculum? And the curriculum could be 3D CAD, it could be engineering, it could be graphic arts, graphic communications, depending on which direction you go with the 2 machines that we just showed to you. So on the MDX50, somebody might be using a program like SolidWorks, or maybe an AutoCAD product like Designer, and they're designing something, but the teacher wants to take this all the way to a finished product. So they're able to, in the classroom, mill the final product that they've been creating. On the graphic arts side, again, this is all a question of output. They're able to design on screen all kinds of wonderful graphics, but without the output device in the classroom, the GS24 vinyl cutter they have no idea of how these graphics are produced and applied. So we're trying to take the curriculum to a closing point of output. And that's what Roland's all about. We make output devices of all kinds.
So what kind of interests me in this is this kind of this this immediate gratification, because I mean, I'm a photographer, and I know in photography, when you're going to photography classes and stuff in school, very often, you'd be taking pictures, and then the class would end, and then it would maybe be next week before you could go in and develop your film, and in the film developing class, and then it might be the week after that before you could go in and maybe print something from that film onto paper. There's kind of this long, drawn out process, and you forget a lot in that. And I guess what I'm intrigued with here is how quickly you can go from the design phase to actually just outputting something, whether it's on a vinyl cutter or a milling machine. And I gotta think that really helps students to learn these concepts a lot faster when they can just immediately design something and almost immediately get an output from it.
You're 100% correct. And that's what it's all about. I think that getting that final result at the end of the day, that brings closure to the learning lesson. It's one thing to design, it's another thing to produce. And we're finding a tremendous number of students that are coming out of school, and what they learned stops at the computer screen. They didn't get the experience of outputting their job, whether it be to a mill, whether it be to a vinyl cutter, whether it be to a printer. And teachers today in the STEM system want to be able to complete this process. They want the student to realize, oh, this is how we produce what we've created on the screen. And it brings closure, it brings things full circle for that student.
So let's talk about, you mentioned teachers and students. We actually have another little clip. It's about a minute long. I guess you might call it a testimonial from, this was a Trumbull Career and Technical Center. So this is a place that has been using, I guess, a variety of different Roland DGA equipment. So let's run that clip, and we'll talk about it after that.
Very good.
By being able to give them hands-on experience with industry level equipment, we're sending students out into college or into the workforce with a leg up. So our goal is to have equipment that is similar to what they would experience in industry, so that it's kind of cutting edge and really preparing those students for their next step.
We designed a life-size car graphic for a student who has a race car. The numbers, the flames, sponsors. We brought in real life situations, which we want to do. That's exactly what we do here.
We also have the MDX 50 mill that we use the engineering students as well, because they do a lot. They learn CAD, and so they're able to design in 3D. They have a small mill in their lab, and they have one 3D printer, but we're able to have more here. And so it just gives them more access to equipment to make their 3D modeling projects come to life as well.
This isn't just important to TCTC. This is important to all the schools, because I think that this type of equipment is going to permeate into all of our career fields.
Students come out of here with so much exposure to things that I don't think a lot of students do have exposure to. And so we're able to just give them that extra boost before sending them out.
I think it was the gentleman towards the end of that said something that I thought was pretty interesting, and I'm kind of paraphrasing here, or the way I interpreted it, was that equipment, and having that equipment, that type of equipment in the hands of student, isn't just important for the students and for Trumbull Career and Technical Center, TCTC, but that it's important for the community as well. I'm just kind of curious about what you think of the impact of getting this equipment into students' hands, whether it's K through 12 or in that case a vocational school, getting into their hands early. What kind of effect that has in terms of preparing people who want a career in manufacturing, who maybe aren't going to be doctors and lawyers and whatever, that they really want to work with their hands. They want to go into manufacturing. How this is kind of setting them up for that.
Dirk, you make the point that not all students are going to go off to a four-year school. Some students might graduate high school, they might go to a two-year school, the end of the day, they need a skill, they need a way to make a living. And by giving these students the opportunity to find out about the complete throughput and how it all comes together, and you end up with the product that you've designed on the screen, well, it just better prepares the student to be able to go into a job interview or whatever and say, oh yeah, I've done that before. I've done cut vinyl graphics in my class. We actually designed and cut graphics, and I know how to do that. Wow, this is great. On the CNC side, not all students are going to go be engineers. Some students are going to become a machinist. If they're going to become a machinist, we give a next step to CNC programming. So I think that preparing students for the real world, as you said, is very important, and STEM education is doing that for people today. Students get to find out what it means to go to the four-year school, or what it means to get a job in industry and do production. That's what it's all about.
All right. Well, that's a great way to wrap this up. Then, Adam Sebran from Roland DGA. I really appreciate you. Desktop mill. Who knew? I didn't even know such a thing existed. Thanks for joining us today.
Dirk, thank you very much. It's been a pleasure.
Okay, thank you. That's all our time for today. And hey, support your local schools. Today's students might be your employees in the future, and it's up to all of us to make sure that they have the tools to help them prepare, tools like what we saw here from Roland DGA. So, as usual, if there is someone or something you would like to see on the show, or some topic you would like us to cover, send those ideas to us at qdl@qualitydigest.com, and I will do my best to bring those people or things onto the show. So thanks for joining us today. We will see you next week on QDL. So long.